In the last video, you saw the qualitative effects of connecting the a voltage to the RC circuit. So here we can measure some of the quantitative effects. So instead of just having the numeric reading from the 2 voltmeters, we use the oscilloscope, and we're going to monitor 2 voltages on the oscilloscope. So we're going to monitor the voltage across the power supply by connecting one of the oscilloscope leads to the resistor on the left-hand side. Then the other one's going to be monitoring the voltage across the capacitor, and we're going to do that by connecting the positive and the negative leads of the channel 2 across the capacitor. So to do that, we need to turn on the second channel. So we do that on this oscilloscope by pushing the number 2 button. And now we have both traces up and running, and they're superimposing on top of each other. You can see there's a little bit of yellow underneath the green. So what we might want to do is separate the traces, and we could do that with this knob here. This is the vertical position knob, and it adjusts where the baseline is. So the baseline is referring to this little number 2 right here, and that number 2 is telling us where the 0 or the ground potential is for the oscilloscope. So we could move that down, say to here, and we know that the battery voltage is 7.8-ish volts. So if we want to see the full scale change, as the circuit steps from 0 to 7.8, we want to make sure our vertical divisions is set up properly. So here we have 2 volts per division for each channel, meaning it's going to go slightly less than 4 vertical divisions, as we step from 0 to the 7.8 volts. So we have channel 1 connected to the resistor right here, and then channel 2 is connected directly across the capacitor. So we're in our initial state where our resistors, left-hand side of the resistor is connected to ground. Like in this picture right here, we have this side of the resistor actually connected to ground to keep the capacitor at 0 volts. And then when we turn on our step function, we're going to take the connection from the ground and move it to the positive terminal. That's going to be like connecting it to the 7.8 volts, and that'll look like a step. So we also set the horizontal scale on the oscilloscope to 2 seconds per division. Considering our time constant is 2.2 seconds, once we get through 5 time constants, we're going to be there. So after 12 seconds, we should basically asymptote to our final value. So now we'll make the change. So we're going to lift the resistor and move it over to the other side. And you could see the yellow is the step function, and the green is the voltage across the capacitor, which is charging up. So when I get a nice long length of time here, I'll hit the stop button, and now I could save this waveform so you can analyze it. Okay, so the waveform is saved. Just to recap what we have here, so we have 2 seconds per division on the horizontal axis, 2 volts per division on both vertical axes, and you can see they're offset, like the number 1 channel, which is the step function, a stimulated step function channel, starts at 0, then it steps up to 7.8. Channel 2 is the voltage across the capacitor, and you can see it charging, as we expect it to, from the transient analysis of the RC circuit.